right? Stack data structure. See, first of all, what is a stack? Stack means arrangement of data in a last in, first out manner. It follows the rule last in, first out. That is called stack. How can we represent the stack? How can we create the stack and all? I'll explain. Suppose if we are taking the stack like this, just consider it's a stack. Let me write the code right here. Suppose consider the size of the stack I'm taking is a 5. Here it is. The size of the stack I'm taking 5. If you want to insert the data we are inserting from the top and the data we are deleting also from the top of the stack. Inserting the data we can call push element onto the stack. See, suppose if you push 10, the 10 will go on store. It will come down and it will store here. Next, we keep on push the values like this. Push 20, push 30, push 40. Suppose we push the elements like this 10, 20, 30, 40 like this. But whenever we pop is also deleting from the top only. So what is the top element? What is the top element that will come first automatically? No need to specify. When you pop, that value is a 40 will come first. Again you pop, that value is a 30 you will come next. So deletion will be like this. Inserting and deletion from the same end called top of the stack. Sir, how can you represent? Using that array only. Normally we are writing array like this. Just stack also only with the name we are changing that one. Every operation is an index based operations only, like 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Like this. 2, 3, 4. Every operation we are performing using the variable called top. It starts with a -1 initially. It starts with a -1. That is simply called top of the stack. It's called what? Top of the stack. Now, how can we code it? And what is the functionality? What is the functionality? And how can we create it? Let me show you. The first one is, let me explain what are the top stack operations. What are the stack operations? Right here it is stack operations. Stack operations and stack creation. Stack creation. Here we can create stack in two ways. One is static. Static means what? Is a fixed size. Using arrays concept. Second one is a dynamic. Right here it is not fixed size, using pointers and CLOC. We know already this. In two ways we can create stack. What are the stack operations? First of all, stack operations, creating the stack. First of all, what are the stack operations? Push. It will take the element, push element onto the stack. Second one, pop, remove top element from the stack. Pop element from the stack. Next one is a traverse. Traverse means what? Display all elements of the stack. Display all elements of the stack. Next one, peak means what? Display top element of the stack. Next one is empty. Check the stack is empty or not. Empty or not. Is full. Check the stack is full or not. That is. These are all stack operations. How can we perform all the stack operations? How can we perform all the stack operations? Simply here, first, complete representation of the stack. Multiple functions we have to create. First thing, globally, I'm writing the variable int stack. Size directly, I'm giving 5, comma, one more variable I'm taking size is a 5. Next one, top equals to -1. Sir, why sir you have written global variables? Global variables means what? You can access everywhere. In a functions called, first one, void push operation. It is taking the element, perform that push operation. Void pop, it will remove that one. Void peak. Next one, void traverse. Traverse means what? Display. Display. Void is empty. Or we are taking integer that I'll tell you. Next one is full. Is full. Like this. The first one is in the main. It's a menu driven program. So while condition is true, always. Now we are giving all one. What are the operations? One is to push the element. Second one is to pop the element. Third one is to peek the element. Fourth one is to traverse or display, anything we can say. Display. Fifth one is quit, exit. Is empty is full, here we are not using. So we ask, enter your choice. Enter your choice. We just read into a variable called choice. CH is a choice. Sir, where is the choice variable? Just declare the variable. Now, based on that, we are writing. If choice is equal to 1. So we need to call the push function. So we have to pass the element that what you want to push onto the stack. So printf, enter element to push. Scanf, %d, address of element. Sir, where is that element variable? Declare that element variable also. Then we just call push function and pass the element. That's all. Second one, if choice is equal to 2, just call the pop function. Pop function. Else if choice is equal to 3, call the peak function. Else if choice is equal to 4, call display function is nothing but traverse function. Else if choice is equal to 5, just giving that end of the program, break. If other than 1, 2, 3, 4, 5, choice is invalid choice. By mistake, end of program, it's an invalid choice. Like this. If it is other than 1, 2, 3, 4, 5, it's invalid choice. Like this, first of all, we have just written the complete skeleton of the code. All we need to write only one thing is a prototype also in C language. Before main, prototype, void pop, void pop, void p, void traverse, int is empty, int is full. Just true or false it will return. That's it. That's why. True or false. We are writing the conditions accordingly. Okay, now first one, enter element to push. Suppose if it is taking the element, now I am coding here. That values are there. Is a 1, 2, 3, 4, 5. 3, 4, 5. With index. Initially, top value is pointing to -1. First it is pointing to 0, 1, slowly it will increase 2, 3, 4. Because size we have taken that 5. Size is equal to 5. Top equal to -1. First, if they call the value push, first of all, we need to increase the top. But before that, we need to check if is full. We are calling the function is full. Then directly we are printing stack is full. Stack is full. Okay. Sir, where is the is full condition? Here. If the condition is valid, then it will return 1 because it's true. Else it will return 0. If stack is full, it will return 1. Else it will return 0. That's why return type is integer. Sir, when it is a full, I'll explain. See, as of now, it will return 0 only because stack is not full. Still it is there. So else block execute. Else block. In else block, first of all, we make the top value 0 because we should make it pointing to this 0th location and store the value into this one. Suppose if you pass 10. So first of all, increase the top value. Then into the array, into the stack of top, store that element. Simple. Printing element pushed onto the stack. Whatever the element you have passed as an input value that you are storing into this top. So you keep on inserting. Sir, next top value 1. Okay. 20. Top value 2. Okay. 30. Top value 3. Okay. 40. Top value 4. Okay. 50. That's it. It's a full. See, when size is of 5 and top is of 4. Nothing but simply when top value equals to size -1. Size -1, we can say that it's a full. It will return 1. If 1 means what? Condition is true. So output is a stack is full. Output is stack is full. Next one is a pop. Whenever you are deleting, we are checking is empty. Is empty. Then directly we can say that stack is empty. Stack is empty. Else printf. Directly we are printing the top value. Top value is a 4 na? That 4 only we need to delete. So first of all, you need to print pop item is simply is a stack of top. After that, decrease the top value, top minus minus, because top has to point into this one. Here only everyone will get one message. Sir, whenever we just write a top minus minus, is it deletes the value which is inside the location? Impossible. It will not delete, but whenever you are inserting an element, that existing value will be replaced. That's all. Old value deletion impossible. Only replacing is possible. So we keep on writing. See, when top equal to -1 initially, if top is equal to -1, because as soon as a top is created, as soon as top is created, I mean stack is created and top is created, that value is a -1. So you keep on deleting means what? It will become 2, 1, 0, -1. When -1, we can say that it's an empty. That is. Peak is also same. See, very easy. Peak means if stack is empty, of course is empty. Else, just print the peak value. That's all. Don't write top minus minus. Don't delete. Only just display what is the peak element and what is the traverse. If it is empty, stack is empty because nothing is there to print. Else, we are printing stack elements are repeating the loop. Repeating the loop from top to 0. Top to 0. All elements I am printing. Percentage D. Simply stack of I. Stack of I. All we need to declare is I. Because look at this. Top is 3 na? From 3, all location values in reverse order 3, 2, 1, 0. Until it is 0, all values are printing. All values are printing. This is the complete code where we are executing. Look at this. Look at this. Enter your choice. 1. Enter element to push. 10. Element pushed. 1. Choice is 20 pushed. 1. 30 pushed. 1. 40 pushed. 1. 50 pushed. 1. 60 cannot push. Look at this. Stack is full. Display 4. All values displayed. What is that peak element? Suppose is it 3. Peak element is 50. How many times you check? Always it is 50. Look at this. 3, 50. But pop is not like that. See, 50 deleted. Na? Next, 40 deleted. Next, 30 deleted. Now peak element is, after 30 deletion, peak element is 20. What is the difference between peak element and pop element? Peak element will display only the top element but will not remove. But pop means what? It will remove. That's it. Okay. This is the only code for today. Everyone please practice this code.